Hello everyone, welcome to the TheGeoecolologist. I am Dr. Krishnanand and you have been watching my videos on climatology and various other topics of geography as well. So in today's session on climatology, we are going to learn about the reversal of lapse rate that we have learned in the previous session, that is about inversion of temperature. So what is this temperature inversion all about? What are the factors and why is it important for us as human beings? So let's understand this in today's session, but before we go ahead, don't forget to subscribe to our channel and share the videos with others as well. So after we have discussed in previous sessions, in previous lectures about lapse rate and adiabatic lapse rate, now it's time that we understand inversion or the reverse of lapse rate as a phenomena which is important for vertical distribution of temperature. So this is called inversion of temperature. So this is reverse of the lapse rate that we see. So in normal conditions, what we have seen is that with increasing altitude, right? Look at this particular image, what happens? Warmer air is near the ground, and as you go in altitude, there is a cold air. This is happening in the troposphere as we know. But what is the reverse case here? The temperature inversion happens where near the ground, you have more cooling, and as you go in height, the temperature starts to increase. So this is particular layer which is called inversion layer, that is here as a warm air. So in this situation, there is a reverse of this lapse rate happening, right? And the process here is already discussed in the previous lectures, that is in the lapse rate and adiabatic lapse rate, that how this dynamism is there in the given parcel of air with rise in temperature, fall in temperature, and how it is linked to the pressure changes as well. So there are numerous other factors that are related to this inversion. Why does this inversion of temperature happen? What happens to this normal lapse rate? In which condition does this change to this inverted one? So what is this process behind reversal? Let's understand further more. So the ideal conditions, it means the normal conditions which are prerequisite, which are most important for this inversion of temperature are basically these three. So what are these three? These are the basic features that we need to understand. The situation must be having longer nights. So if longer nights are there, it basically means what? The outgoing radiation. Remember, Earth radiates energy which absorbs in the daytime. So this outgoing long wave radiation gets more time to get released, right? So Earth is actually cooler here. If we have longer nights, then Earth is cool. Why? Because most of the temperature has now gone up, right? So ground surface temperature and air near it is actually cool. So this is where longer nights are important. Then clear skies. Now remember, if the sky is not clear, if it is covered with a cloud, then it will act as a shield, right? So if it will act as a shield, the temperature will not be able to escape. So temperature will be hotter in this particular zone. So if it is clear, it means this is not there. So this entire temperature through long wave radiation will escape freely. So it will be unobstructed escape of radiation. That's why clear sky is important. And third factor is calm and stable air. So remember, if there is a turbulence in the air, if it is having this convection cycle going on and lots of intermixing happening, changes happening, then there will be no vertical mixing at lower levels. So for this smoothness transition, what is important is that there is a calmness or a stability in the air situation. So these are the three major factors that we see, or major ideal conditions for temperature inversion. So now you know that logic behind how this reverses, because now the ground is cool and upper air is warm. So if you go from ground to upper air, in normal condition it would have been reduced, the temperature must have gone down. But in this situation now, when you go up, the temperature here is warm, so temperature goes up. So this is a reversal case of the lapse rate that we discuss in inversion of temperature. So various causes are listed in this particular flow diagram. So clear skies, longer nights, higher pressure system, lots of moisture, calm atmosphere. Now we already know these three factors: clear skies, longer nights, and calm atmosphere. Lots of moisture is related to, again, remember, the moist adiabatic process which we have discussed. So adiabatic process where there is a change of the system internal heat release, that is because of the condensation, that is latent heat of condensation coming out of the moisture, that is important. So that may lead to the change, that is warming of that air parcel. And then high pressure system. So this is basically a pressure temperature relationship. High pressure, it will lead to what? It will also lead to this warming, and then a stable layer of warm air high in the atmosphere will be actually created. So these are the major reasons, ideal situations in which temperature inversions happen in the atmosphere. That is what we are studying here. We understood that why it happens, but what are its effects? Now understand that due to this reversal of this temperature lapse rate, normal lapse rate, the inversion factor, what happens? It plays an important role in determining cloud forms, precipitation and visibility. So remember these three factors when you're writing an answer. Always remember that this is what it actually affects: the formation of clouds, which is responsible for precipitation, and also visibility on the ground. So this is important to understand, that if you have this inversion of temperature, then there is a foggy situation, visibility on ground also reduces. So inversion acts like a cap. Now remember, look into this diagram. What is happening? In normal situation, there was a cool, smooth transition. But now what happens? This long wave radiation, which comes from this terrestrial surface, is now not able to escape this layer, because this layer is this inversion layer where you have warmer air, right? And what happens? The cooler air is here, subsided down. So remember, warm air is that particular layer which is released and creates a shield. It's like a shield here. It's like a cap here. So what happens? This does not allow this moisture addition to go up and form clouds. So cloud formation is hampered, precipitation is hampered, and also there is a foggy condition near the ground because this entire water vapor is trapped. So that is why it is important that inversion of temperature affects us as human beings as well, and also this entire process related to this terrestrial radiation near the closed surface, atmosphere near the ground surface. So diffusion of dust, smoke and other air pollutants is likewise limited as well. So what happens if we are producing dust here, then smoke here and other air pollutants? Now what will happen? It will be trapped inside this particular zone only. It will not able to escape. So what will happen? This entire zone will have this problem of air pollution and also of this particular visibility problem. So many times in winters what we see is that ground is cool and upper air is warm because of the same situation, inversion of temperature, and then we have this entire foggy situation mixed with the pollution. They also form smog. So this is very famous in urban pollution these days, that smoke and fog combined together and they keep hanging and they have lots of issues on human health. So this is the situation that inversion of temperature creates, and this is one of the impacts or effects that we are learning here. So in regions where pronounced low level inversion is present, now remember this statement that if there is a pronounced low level inversion, convective clouds cannot grow high enough to produce showers. So what happens? If there is not that elevation where this entire cloud formation can happen, what will happen? There is not enough of showers. It means rainfall will not happen in this particular situation, which normally it would have happened if this inversion layer would not have been there. So that is where it is important for this rainfall or precipitation as well. Now as we were talking about visibility, just look into this image. This entire city down here in this particular area is now under this entire cover, that is fog cover, you can see here, and this is where visibility is actually obscured or greatly reduced because of these inversion layers, and also because ground layer has human beings and humans have this contribution of dust and smoke to this atmosphere, so that also leads to it. So fog is frequently present in this situation, and remember, inversions also affect diurnal variations in temperature. So why does it impact diurnal variations, that is daily range variation of high and low? Because if there is this layer which is like a shield here, the temperature of this particular layer between point A and point B will be almost fixed, right? And then it will not be able to escape. So high and lows will not be of that particular situation as in a normal situation there is. So this range of temperature is also impacted. So that is also important in terms of climatological phenomena where we say inversion of temperature. Now the next part of this session is the types. So now it has various types, and let's understand one by one that what are various types of this inversion of temperature. So the first one is called frontal temperature inversion. The word itself here is frontal. In details, when we study air fronts, there we discuss various kinds of fronts, but for this consideration here in terms of temperature inversion, just remember this is this particular front. The front is which is the boundary of this particular where this air and this air is interacting. So it is at the front, it's like at war. So on the front, when warm and cold fronts meet, what happens? The warm front rises above, so warm air will rise above automatically and cold air will go down automatically, right? So now in that situation, what happens? Automatically you understand that this is the ground. Now cold air is near the ground and warm air is hanging above. So if you go, what will happen? Normally it should actually decrease, but in this case temperature will increase. So this kind of activity is called frontal temperature inversion, where warm front and cold front meet. It often occurs in temperate zone, which is also called zone of mixing. So in this zone, what happens? There is a cyclonic conditions created because of this kind of situation. It is called frontal or cyclonic inversion as well because of this reason. So remember, inversion of temperature in this temperate zone is also known as cyclonic inversion, and it is caused due to this temperate zone's fluctuation and mixing of air, warm air mixing with the cold air. So it is formed due to convergence factor. The catch here is convergence of warm westerlies and cold polar winds in northern hemisphere. Then the next type of inversion is called vertical advection. Now remember, the word here is vertical. So it is basically in terms of the mountain and valley system, where you have a rise and fall of the altitude. In this situation, when there is the transference of heat, so what happens? At valleys where the air is, the valley gets heated. In daytime, what happens? The valley, this portion actually is where the entire heat is accumulated, right? And gradually it cools down, and then what happens? The air moves up because warm air goes up and cool air goes down. So this is the situation at night and day fluctuation. So if you look into this image, what you observe here is that in daytime there is warming of mountain sides, and remember, warm air rises up. That is the nature. So warm air is rising up, and when it is rising up, in normal lapse rate situation, it cools down, and cool air is heavy, it subsides down. So at night, what happens? The cool air actually comes down, it occupies the entire mountain valley, and warm air is actually here in the upper atmosphere because of this terrestrial radiation, long wave radiation. So there's this inversion of temperature where you have night situation. Right? So in night, if you go from the bottom of the valley to the top of the mountain, you'll find there is an increase of temperature in this situation, right? This is called vertical advection and inversion of temperature of this vertical advection type. And remember, it is also called air drainage type of inversion. It's like drainage of air, circulation like a drainage system occurs, right? So if you look into this image, it's like a drainage flow from the higher slope to the lower slope, right? That is how the drainage comes. So from this situation, it flows like this, and then you see warm air is going up, cool air is flowing down. That's why it is called air drainage type of inversion as well. Now the third type is called radiation inversion. Now remember, the key word here is in the name itself. Remember, radiation based inversion. So during the daytime, what happens? The sun heats the earth and air near it is also heated. So at night, the ground and the air near it cools faster. What happens? During the night, this ground releases the heat, right? And unless if there is a obscurity or the blockage in normal situation, the warm air is up and cool air is here at the ground. So again, warm air is up and cool is down. It means if you go from cool to warm, there is a reversal. And this is only because of this radiation factor. Nothing else. So where radiation is prominent, there it is radiation based inversion. So that is important here to remember, radiation inversion of temperature. Now this is also called non-advection inversion because it occurs in static atmospheric condition. This is also called non-advection inversion. Now when we say again this advection word, what do you get? Advection is basically what? Carrying along. So this carry along factor, remember the basic word advere, it means in Latin to carry along with you. If you're carrying something along, that process is called advection process. But what is happening here? It is called non-advection inversion because it is a static atmospheric condition. Nothing is being carried out here. So there is no movement of air. So nothing is being carried. The earlier was advection. As we remember, the air carries the heat from mountain to valleys and valleys to again the atmosphere. So it is called non-advection. And there is no movement of air, whether horizontal or vertical. It's purely based on the radiation factor. That is why it is also called non-advection inversion. So remember, wherever this word advection comes, just remember it's like carrying your bag on your back and you're walking. So you are carrying something. So where wind, where air, remember it carries heat. That is what is advection. And the fourth type is called subsidence inversion. Now the word itself is subsidence. Something is actually sitting down, subsiding down, falling down, right? So that is important. And it is associated with the anticyclones. Now in details, when we study anticyclones, you'll understand how this process operates. But for here, remember that if there is cool air, right? What will happen to the cool air? Hot air rises up and cool air comes down, right? So cool air will actually come down and hot air actually will be in the upper layer. So that is the important thing. So in anticyclonic formation, this kinds of thing happen that there is a descending air compressed and warms adiabatically. So this upper layer of air which was cool is actually going down now, but while descending, this actually layer of air gets warm due to adiabatic process. Now remember, adiabatic process of lapse rate we have understood. While descending what happens, while ascending what happens. So when it is warming because of this particular latent heat of condensation in this situation, remember this air becomes warm and it again creates a shield here for this terrestrial radiation to actually not escape out. Right? So what happens? This near ground is cool and this subsidence layer becomes the hot layer. So if you go up, you'll find it is warming. This kind of inversion related to anticyclonic circulation happens as well, which is called subsidence inversion of temperature. So now, when we have understood about the inversion of temperature, its various types and factors associated, in the lectures to come, we are going to look at the other topics of climatology. So stay tuned, stay safe, and all the best wishes.